All right. So let's talk about non-renewable energy sources. So non-renewable energy sources, first off, are energy sources that have a finite amount to them, um, meaning that when we use them, they can't be replenished. Um, and so as a result, when they're gone, they're gone. And so that's why we call them non-renewables. They don't replenish over time, at least not in time that's convenient to humans. It takes millions of years for fossil fuels to build up. Um, and so, unfortunately, it would take millions of years for us to replenish. That's non renewable, all things considered. That's non renewable. So, there are three main non renewable energy sources: coal, oil, and natural gas. And I'm going to talk very briefly about each one of them. I will admit that maybe this might even be a little bit biased towards the negatives of each of them, but that's because there are some major trade offs to them. Um, but let's talk about them. So, first, coal. So, coal is basically solid, compressed, dead organic material. Um, Basically, what it is it's stuff that has been buried deep below the surface of the earth for many, many millions of years. And as things on top of it built up on top of it, it became so compressed that it solidified. It actually underwent a process called lithification, where it solidified into solid rock. Basically, just a giant lump of carbon. And one of the things about coal is when you take it out, it's actually very easy to find. It's very easy to find, which is one of the reasons why we rely on it so much. And when we take it out of the ground, it burns very easily. Now, that burning results in or is a result of combustion. So that's carbon mixing with oxygen to produce carbon dioxide. That reaction triggers a big burst of energy, and then we use that energy to run things. We use it to run our trains, we use it to run our cars, use it to our power plant, and so on and so forth. Well, one of the big negatives is, in addition to carbon dioxide release, coal also has impurities in it. It's not just all carbon. No, there are actually other things mixed in. There's nitrogen and sulfur that are oftentimes mixed in this, not in large amounts, but in amounts big enough to care about. And so when coal combusts with oxygen, these things, sulfur and nitrogen, are also combusting with oxygen. And so, in addition to carbon dioxide, sulfur dioxide and nitrous oxide, and nitrites and nitrates are also being released at the same time. They're also being released at the same time. Now, obviously, that has big pollution issues behind it, and those are greenhouse gases that we kind of have to worry about. Not so much sulfur dioxide. Sulfur dioxide actually does something else, but they actually have a much bigger consequence to them. Both of these gases, sulfur dioxide and then these NOx gases, nitrogen oxide and nitrogen dioxide, these gases are very reactive with water. And our atmosphere has water in it. So what happens over time is, as these gases rise into our atmosphere and as they get fed into clouds, they react with a lot of the water in those clouds to produce sulfuric acid, up here H2SO4, which is really, really, really corrosive. I took a chemistry class when I was in college. It was my first semester. I was 18 years old. In my opinion, I was young and dumb. And I decided one day in my chemistry class to see how bad sulfuric acid was. And I actually took a transfer pipette, one of those little eyedroppers, extracted some, and then dropped it on a paper towel. And it looked like the paper towel had been caught on fire. That is how corrosive it was. So that is a very corrosive acid. And then nitric acid is also a very corrosive acid. So these things are reacting with water vapor to produce these really, really gnarly acids that then actually get mixed into the rain to produce acid rain. And so acid rain ends up becoming a big component, a big byproduct of coal combustion. A big component of coal combustion. Here in the western half of the United States where we live, coal combustion is actually not a huge source of electricity generation. And one of the reasons why is we just don't have a lot of coal out here. However, in the eastern half of the United States, the Appalachian Mountains, West Virginia, that whole area, that is like a coal producing world. I mean, that's one of the reasons why District 12, where Katniss Everdeen comes from, that was actually in what would be considered the northeast of the United States. And their big industry was coal. And it's because that is where the coal is. So a lot of the electricity plants in the eastern half of the United States are reliant on coal. Well, here's what that's actually done. Because of that reliance on coal, the rainfall in the eastern half of the United States is much more acidic than the rainfall here in the western half of the United States. And the way that we actually determine this is by looking at what's called the pH. And I don't have a lot of time to go into like what pH represents and everything. All you need to know is that the higher the pH, the more basic the water is, the lower the pH, the more acidic it is. And then 7 is what we consider neutral. So all of our water all around the country is slightly acidic, and that kind of makes sense because water reacts with carbon dioxide. Pure water would be considered neutral. There are some waters that are actually basic that are have scores higher than 7. But all you really need to know is the lower the number, the more acidic it is. And if you take a look, pretty much everywhere east of the Mississippi River, which is roughly right here, that's the Mississippi River. I guess if I'm being true, it's more like that. Pretty much everywhere east of the Mississippi River has pH below 5. You have 4.9, 4.8, 4.5, 4.6, 4.4. So they have very acidic rainfall there. West of the Mississippi, where we live, it's a lot closer to mid to high 5s. There's even a few 6s scattered around there. I will admit, just for the sake of transparency, I'm showing you a 2008 map. The reason why is that more recent maps have actually shown that the pH of rainfall in the Northeast United States has actually improved. The reason why, though, is because coal use has actually declined in the eastern United States. They aren't getting as much of their energy from coal now, and so the acidity is improving there. We'll actually talk about that in 2 weeks when we talk about policies called cap and trade policies. But I did want to at least highlight that this has historically been an issue in the eastern half of the United States. So that's coal. Natural gas. So the bulk of our remaining electricity that comes from fossil fuels comes from natural gas. Only a teeny tiny little bit actually comes from petroleum. And we'll talk a lot more about petroleum next week. But natural gas is the other big source. Natural gas is mostly methane. There are some other hydrocarbons in there. Those are things that contain both carbon and hydrogen and also sometimes oxygen. Things like propane and propane accessories. Those are the kind of things that natural gas are made out of. The idea behind natural gas, and one of the reasons why it's actually been touted as sort of a clean alternative, is that, one, natural gas is a lot cleaner burning than coal or oil. it's a lot purer than coal and oil. You don't get black carbon on the other side. You don't get a lot of those impurities. You don't get sulfuric acid. You don't get acid rain or anything like that. The other big advantage of methane and natural gas is that if we were to instead allow this gas to rise out of our ground and rise up into our atmosphere, it's a much more potent gas than carbon dioxide. So it makes more sense to burn it. That makes it less potent by converting it to carbon dioxide, and it gives us a lot of residual energy. So it's one of the things that many scientists have sort of, and many policymakers have sort of touted when they've talked about natural gas. So it can be extracted from oil wells, coal beds, deposits, and even landfills. When little bacteria are decomposing things, a very common byproduct of that is methane. As well as oil wells, methane comes out of those, coal beds, oil comes out of those. However, and as I mentioned, it is cleaner burning than coal or petroleum, which is one of the reasons why it's been so attractive. It emits less greenhouse gases and much less black carbon, much less of those other really dirty gases. But it is a non-renewable resource. And in fact, the reality is that because we have actually sort of switched over to natural gas, we've kind of pulled away from coal and pulled over towards natural gas over time, that has actually made our natural gas supplies lower and lower and lower. Well, the natural gas industry has actually found a pretty creative way to fix this problem through a process called hydraulic fracturing, or as I'm sure many of you have heard it as fracking. So what actually is fracking? Well, the idea behind fracking is that deep beneath the surface of the earth, beneath the water table, in the shale, deep below the surface of the earth, so below the water table, lower than that, there is actually all of these little fissures, these little cracks in the ground. And embedded in these cracks are bubbles of natural gas that came from bacterial decomposition and so on that have just been there. They've just been trapped down there. Well, the idea behind fracking is if you can pump some kind of hydraulic fluid into those cracks, that fills up those cracks and that forces that natural gas to move out of the way. So basically the idea is you're pumping fluid in and that forces natural gas out. And hydraulic fluid is usually some kind of chemical mixed with water and sand. So it's what's called fracking fluid. And as the USA is shifting more towards natural gases, we've sort of been trying to pull back from coal. And as we're not quite yet in renewable land, we have been shifting a lot more towards electricity generated by natural gas. Well, unfortunately, the problem with fracking, so here's how fracking works really quickly. Deep beneath the water table in the shale, down here deep beneath the water table, there are fissures in that shale. And trapped in those fissures are bubbles of natural gas. So basically, if you can pump fracking fluid into that into those fissures, that can actually cause the natural gas to then come out of those fissures and pop back up, and then you can take them and use them. Kind of a cool deal, if you ask me, in many ways. Like, actually kind of a cool deal. Here's the problem. First off, in order to even get down to the shale, you actually have to go through the water table. Well, the water table is actually a source of potable water for much of the United States. Even here in California, a lot of our water that doesn't come from the Sierra Nevada comes from groundwater. You ever wonder why San Jose's water sucks so much? A lot of it is groundwater that is taken from aquifers. Well, when you have a pipe that is going through an aquifer and you're pumping it with high pressure fluid, it's very easy for the seals on that pipe to crack. All you need is just a little bit of cracking or a little weakness, a little unsealing to happen. And all of a sudden, all of this fracking fluid contaminates the water table. And therefore, it makes the water that you and I drink a lot more unhealthy. So, I mean, San Jose water already sucks. This is going to make it suck even, and in fact, may make it actually unsafe to drink. So that's one big negative with fracking. Another big negative with fracking is that fracking basically disturbs our crust. So we have all these cracks that are down in the shale, deep beneath the surface of the earth, and we're pumping stuff into them. That is unsettling the crust of our earth. And guess what? When you start unsettling the crust of our earth, causing more cracks, causing more disturbances, causing more ruptures, all of that put together actually leads to more earthquakes. Now, the good news is here in California, we've already got enough earthquakes. We are not a major fracking state. In fact, there's a lot of pressure for us to not frack at all here in the United States, or we will not frack here in California. However, Oklahoma, specifically Oklahoma City and everywhere north of Oklahoma City, that whole area has basically been fracking central. And there's a lot of fracking that's happened in Oklahoma. Well, here are the consequences of that. And most of it's been in this last decade. So the consequences of that, prior to 2009, over roughly a 30-year time period from 1980 to 2009, that's 30 years, from 1980 to 2009, every one of these dots represents an earthquake. And then the bigger the earthquake, the darker the dot and the larger it is. And so this represents the Oklahoma City area. Right here, the Oklahoma City area, in 1980 from 2009. This over here represents just an 18-month period from the beginning of 2014 to June of 2015. Look at how many more earthquakes there have been in that area. Coincidence? I think not. No, a new tectonic plate is not developing over Oklahoma City. This is because of fracking. We have disturbed the crust, that shale deep beneath Oklahoma City. And so by doing so, we've exacerbated cracks, we've created more fractures, and voila, we're getting more earthquakes. Now, that might not seem like a big deal, and most of these are like 3.0, 4.0, 2.0, a few fives. Here's the thing though, a 5 here in California is you get underneath the table really quickly and then you go on social media and talk about it. That's it, no big deal. It's definitely noticeable. It might knock over a bookshelf at worst, but we're built for those. Oklahoma City and its surrounding area is not built for those. No, Oklahoma City is built for tornadoes. They're not built to withstand earthquakes. They're built to withstand tornadoes. Their buildings are built and reinforced in a different way than California's are, so they're more susceptible to earthquake damage. As a result, they're much more vulnerable now. They're much more vulnerable now. So that's pretty much the non-renewables. A very, very tiny fraction is actually oil power plants. We usually reserve most of our oil for transportation, and we'll talk about that in the next module. So in the next video, however, we're going to talk about those kind of they're not renewable, but they don't really have much of a greenhouse impact either. So that's what we're going to talk about in the next video.